Okay, now we'll find the resultant force and acceleration, in this case with friction, and also on an incline. The incline is 30 degrees. I think this is not to scale, this is more like 45 degrees, but we'll work with that. So there's a few things that need to be adjusted here. We also have forces that are not at 90 degrees. So we're going to take the normal force to determine what effect friction has. We're also going to take the balance of forces in the ramp direction. So this is important, so we need to define the direction of positive x direction. And we're going to take the ramp direction, and this makes it easier in a couple ways. So when we take it in this direction, let's work with one item at a time, and we'll work first with the normal force. So the force in the normal direction, we're talking about normal meaning the normal off of the surface. So this direction, so we're saying what is pushing down or pushing up. I don't think we have anything pushing up. We have the weight of the item, and we have a portion of this one component pushing down and a portion of this force pushing down. So let's add those up together. We have 300 newtons, but we don't have all of the 300 newtons in this normal direction. We have the cosine of the same angle, 30 degrees. And then we also have another item, 100, pushing down, sine of 25. And another item is 500, but only a portion of that, cosine of 20 degrees. And that total normal force pushing down is 771 newtons. Okay, we'll need that to determine how much effect friction has. The next item we can look at is in this x direction. Okay, we'll now calculate the force in the x direction down the ramp. Collecting all of these items, there's 1, 2, 3, 4, 5 that have effect on the direction downward. Collecting these, we would have the initial weight and the sine of the 30 degrees. We have this force downward, 1050, 100 times the cosine of 25, also downward. And now we have an upward force. We have upward force of 300. And up the ramp we have a component of the 500, and that would be sine of 20, that component, the sine. That works out to be 775 newtons, and that's positive, so it's downward, down the ramp, as defined by our x. So the force of friction, the static friction force, would be our 771, the component of the normal force. Force of friction is the normal force, which is the combination of these two and the weight, times this coefficient of static friction, and that gives us 540 newtons against the motion. And that is smaller than the force down the ramp, so it does move. So the total would then have to be related to the kinetic, because it does move. It's no longer static, but kinetic. So the same normal force times the kinetic, and that gives us 463 newtons. So the combination here would be the force total would equal 775 minus the kinetic friction, always against the action, and that gives us 312 newtons down the ramp. The mass of our item is the 300 newtons force on the item divided by 9.81 gravitational acceleration, and that gives us 30.6 kilograms. So our total force, we have a mass, and now finally the acceleration. Acceleration down the ramp would be acceleration is the force divided by the mass, and that gives us 12.6 meters per second squared.